Okay, today we'll discuss one more problem. A plain carbon steel of a grade 45C8. This is a material grade 45C8. For that, yield stress is 360 MPa. Okay, the yield stress for this 45C8 steel. Okay, the yield stress is 360 MPa. Is subjected to an tensile load of 60 kilonewton. Subjected to a tensile load of 60 kilonewton. Calculate the diameter of the rod. Okay, calculate the diameter of the rod using the factor of safety 3. Okay, calculate the diameter of the rod using the factor of safety 3. Okay, so here, if the value, very important note, if the value value of stress the value of stresses is not given is not is not given, then refer table 1.6 slash 1-6 in the design data handbook. Okay, if that value of stress, yield stress, which is not given for this grade, okay, at the time you need to refer this table to get the value of the stress. Okay, next, let us, okay, note down the given data. Okay, the given data, what is the value of F? Okay, the tensile load F is equal to 60 kilo Newton. That we can also write into 60 into 10 to the power 3 newtons, which is tensile. We know factor of safety F is equal to 3, and yield stress sigma y is equal to y or yt is equal to 360 Newton per mm square, and we don't know the diameter. We need to find out the diameter of the steel rod. Okay, diameter of the steel rod. Okay, we know the formula for the working stresses. Okay, therefore working stress sigma is equal to sigma yt divided by FOS. Sigma yt divided by FOS. If you substitute that value, okay, okay, sigma yt, the yield stress, is equal to 360 Newton per mm square divided by factor of safety is 3. Okay, if you simplify this, we'll get 120 Newton per mm square. We'll get 120 Newton per mm square. Okay, for tensile load, for tensile load, for tensile load, okay, for tensile load, sigma is equal to F by A. For tensile load, sigma is equal to F by A. Okay, so if you substitute that value, we know the sigma, working stress sigma is equal to 120 Newton per mm square. Okay, 120 is equal to 60. We know load, tensile load of 60 kilonewton. Okay, 60 into 10 to the power 3 divided by, what is the formula for area? Okay, so which is 5 by 4 into d square. Okay, 5 by 4 into d square. If you simplify this, okay, the diameter of rod diameter of the rod d is equal to 25.23 mm. So as per the design data handbook, the table number 14.6, as per the design data handbook, okay, we just round up this value to 30 mm. Okay, 30 mm as per the design data handbook from, okay, table from table, okay, from table 14.6, table 14.6 in the new design data handbook. New design data handbook. Okay, we'll round up the diameter. D is equal to 30 mm. This is the diameter of the rod. Diameter of the rod. Okay, this is the given problem is a plain carbon steel of grade C40, okay, 45 C8. Okay, for that yield stress is 360 MPa, which is subjected to tensile load of 60 kilonewton. Okay, for that we need to calculate the diameter of the rod by using the factor of safety of 3. Okay, so if okay, very important, if the value of stresses is not given in the problem, at the time we need to refer, okay, for the table number 1.6 for this grade, okay, C45 C40 so 45 C8 or whatever it may be, okay, whatever the grade. Okay, for that we need to refer the table number 1.6 from the design data handbook. Okay, so which is a given data is F is equal to 60 kilonewton, FOS is 3 and yield stresses is 360 Newton per mm square. We know that working stresses sigma is equal to yield stress divided by factor of safety. We know that yield stress 360 MPa divided by 3, the factor of safety, which gives 120 Newton per mm square. This is the working stresses. For tensile load, okay, for tensile load, sigma is what is the tensile load? Sigma is equal to F by A. Okay, we know sigma is equal to 120. We know F is equal to 60 into 10 to the power 3, and we know the formula for area, A is equal to 5 by 4 into d square. Okay, if you simplify this, we will get the diameter D is equal to 25.23 mm as per the new design data handbook. The table number 14.6 will just round up this value to 30 mm, because okay, we will not able to manufacture, okay, a shaft at a diameter 25.23 mm. Okay, we will go with higher number. We'll just round up this value to the higher number because of interchangeability of the products from one company to other company. Okay, it is very easy to assemble the shaft as well as the hole. Okay, thank you.